Okay. Thank you. Oh, okay. Good afternoon to all of you, sir. Okay. So I am introducing Dr. Harsh Verma. Dr. Harsh Kumar Verma is the senior principal scientist and head Mining Science Research Group (CSIR) and CINFR Regional Research Center, Bilaspur. Am I right, sir?
Yes, sir.
Okay. Dr. Verma is also professor in academic SIR and guiding PhD holders in their research work in the area of rock mechanics and rock engineering. Dr. Verma is mining engineer and hold PhD degree from IIT Roorkee, civil engineering. His area of research is engineering rock blasting for construction of underground infrastructure. He has published more than 50 research papers in various national and international journals. Completed over 100 industry-sponsored research and consultancy projects. He also holds patent on a new solid blasting technique. He has received various awards and member of various professional bodies such as International Society of Explosive Engineering, Tunneling, Internal Association ISRMTT, MGMI, Kolkata. Recently, he has been awarded CSIR Technology Award, a prestigious national award for his contribution in infrastructure projects. Am I right, sir?
Yes, sir. Please continue.
Now I will request Dr. Harsh Kumar Verma to present his talk.
Thank you, Professor Anusab, and good afternoon, everybody. It's a pleasure for me to be a part of this learning session with such a pan-India presence. Sir, am I audible to everybody now?
Yes, you are audible and visible both.
Your voice is
And my screen is also visible to everybody?
Yes.
Great.
Voice is not clear.
Okay, so thank you very much, sir.
Okay.
So, sir, thank you very much for such a kind word. And friends, I would like to share my talk, which is primarily on engineering rock blasting operation for underground infrastructure projects.
Okay.
And I have gone through the list of the participants also, which mainly consists of civil engineers, geotechnical engineers. They are from different background. And this blasting being a domain of this what is called mining engineering profession. So I was actually had a tough time how to concise it and make it conversant so that the terminology and the techniques, it becomes easier for everybody to understand. So I have tried, and I hope I will be able to explain you some of the things. And please do not feel any hesitation to contact me over mail. I will share my details also with you all. So basically, I am from CSIR, Central Institute of Mining and Field Research. I was in Roorkee actually. This year only I got transferred to Bilaspur, and we are opening up a new center, which is basically a Center for Rock Mechanics and Rock Engineering Research Group. And we'll be doing mining projects as well as infrastructure projects. What I have done is actually in this presentation, I have prepared it in such a way that I'll quickly try to take you to different sites wherein actually I'm associated with. And with that, I will try to give you some idea what are the things which is actually happening in construction projects. Particularly, emphasis will be on the rock blasting operation, the control blasting techniques. And with that, you will be able to appreciate what are the things that can be actually obtained with drilling and blasting. So far, we have been hearing that drilling and blasting is always having a damaging impact. But there are some beautiful outcomes with the help of this drilling and blasting system, which I would like to share with you all. Then with this background, actually, I will try to go into little deeper details. The blasting science, what is the mechanism, how does it work? And the most important part is all through this, I will try to explain what will be the perspective of geotechnical engineers, civil engineers, because I understand most of you will not be exactly into execution, but you will be part of system and you need to understand some of the things when you are going to what is called the quality monitoring system part. So then I will also take you to the tunnel blast design, what are the guiding principle, and you and me, both as a geotechnical engineer, how we can have a cross check on the systems. All through this, there are some key issues, which is control blasting technique, which we normally come across quite frequently. So what does it actually mean? And I will try to explain that. Then for we as a civil engineers, excavation damage zone is a very, very important part. When we take blasting, inherently it creates some damage to the surrounding rock mass. So what are the things? What is the extent of damage? How we can measure it? So all those issues I would like to keep in front of you. Then all through this also I would like to update you with the updates, the recent technological advancements in blasting science. And all through this case studies I have tried to focus so that it becomes easier for all of us to understand. It is mostly photographic presentations, not more of the theoretical background. You will, of course, you will get some of the things, but for more details, actually, we can have a different conversation. But because for the larger audience, actually, I have prepared this in such a way that it can be easy to understand for all of you. So with this, let me take you to the first slide. As we all know, this is, I think most of you can identify with the photographs itself. This is one of the most prestigious projects of Tehri hydropower complex. And this complete project, actually, it is excavated with the help of drilling and blasting system. If you see this PSP 3D layout, left bottom, this is such a complex underground structure, and this will be running, really constructed close to the underground structure, which is already in operation, which is at my right side, which is what is called Tehri hydropower. So this is Tehri hydropower on my right side, and close to that, actually, there is a PSP we are working on. And this complete is actually, this complete underground structure is right below the hilltop, what you are seeing in my right top corner. You can see the dam structure, earthen dam structure. So this is one of the most beautiful structure, and I would like to say you, I would like to present you some of the critical excavation that has been done in this particular project with the help of the drilling and blasting system. If you closely see this, the dash line, this is basically the old hydropower structures which is already in operation. And the one which is in different colors, blue and green, they are under excavation. And you can see, I don't know how much, see, the blue color you can see PSP K1, right? That's powerhouse K1. And that is very, very close to existing operational hydropower structure. And if I show you simple diagram, see this. The one which is at my left top, that is basically machine hall, where the hydropower generation is continued. And to this machine hall, the powerhouse basically, the main access tunnel is edit 3, which is in my left bottom. Now, if you see the right top, you can see here the distance between existing edit 3, that is my left bottom, and the new bus bar excavation, that is hardly at a distance of 2.6 meter. And you please mind the size of excavation which is going on. Edit 3 is almost 10 meter in dia. The bus bar is also almost 8 to 9 meters in dia. And this has been completed very recently. I would like to show you some photographs of that particular project. this particular excavation, you can see here, this is a major breakthrough recently around a couple of months back. So what I mean to say is, even in a very, very difficult situation with a distance parting hardly less than 2.5 meters, 2.6 meters, excavation can be done in a very, very controlled manner. Of course, it took some time for us to get a breakthrough, but fortunately we could do it. This is another powerhouse PSP, you can see. I will show you the next stage also with the current stage. And then the breakthrough of the butterfly wall chamber, my top, right top. This is the machine hull. This was around 3-4 months back. Now you can see the kind of opening within the same span actually. There are large number of openings within the same structures, parting less than 10 meters, 15 meters like that. This has all been excavated with the help of drilling and blasting system. And it is a large cavern of almost 200 meters size. This is what is happening now. The machine hull is getting ready. 2 turbine pits are actually, the mechanical systems are getting in progress. Coming to the next one, this is almost 22 meters are soft. This is also under excavation with the help of drilling and blasting system, and it is very, very critical. You can understand 22 meter underground search soft. Okay, this is another photograph of Pune metro site actually. What I wanted to show here is there is a civil court actually, which is at a distance of 20 to 25 meters, and this excavation is going on. See what is happening when the judges are there close to your construction site. You have to be very, very careful, and the kind of precaution that is in place. And this whole is, there is tunnel which is going below this building, and this is completely excavated with the drill and blast system. So the vibration limit, which is very, very stringent, particularly in our Indian condition, then there is another further restriction by Supreme Court. They are allowing 2.5 millimeter of peak particle velocity, not more than that. So we need to be very, very careful for excavation within drilling and blasting system. This is one desilting chamber. You can see there's such a large cavern. This is a TSDC project, Vishnu Ghat Pipalkati Hydro Power Project. I'll go to the next one. Now, actually, this is what I was actually trying to explain you. This is partly extension of what this Professor S.A. Gupta Saab was from Mumbai Metro. He was explaining, and I am associated with them for this drilling and blasting system. This is basically a case of Kalwa Devi Metro Station. This is a 3D diagram, and this complete NATM excavation is to be done with the help of drilling and blasting system. And this complete structure is just 15 meters below the surface level. And if I further show you, you can see different edits, which is in green color. There are edits which are all completely to be excavated. And if you see from the top, this is the case wherein you can see high-rise buildings which are in very, very dilapidated conditions. Even a small amount of vibration can actually create a problem. And apart from this, actually there is another fight for human perception also. As Gupta Saab has told today morning, people are residing in these houses, and one is damaged part actually, but the second part is basically how they are going to perceive the vibration. So it's a complex urban built environment wherein you will have to complete this excavation, and you can see at the bottom actually, bottom right. I will show you some more photographs also, then you will be able to appreciate that. You see this? This is how small progresses we are doing, but I tell you, in the background of this, before starting to this drilling and blasting system, they were doing what is called with the help of splitters, and more than 200 holes. You can see in my left top, the small holes, what they were doing, they were basically for splitters. And with this, they took almost 24 hours to advance 30 to 35 centimeters. Now, with the help of drilling and blasting system, we are able to advance 1.2 meters in 24 hours cycle time. So you can understand what is the kind of impact on the economy and the project cost, not only in terms of the investment, but also in terms of progress of the work. this I will actually come to this. What I just wanted to show you, the first left figure you see, there are few rings actually, you can see in yellow marks. Then gradually I'm going to use a term which is called progressive enlargement. Please keep it in mind. This term is, I'm going to quite often repeat this because this is very, very important in our drilling and blasting system. You can see the first thing in my right top, that's something, the results of blast after first touring, and then it is gradually enhanced, and then again it is enlarged. So I can show these pictures actually. I will come to that also. You can see the next stages. And in my right bottom, you can see the kind of progress that we have achieved in this underground central cavern. So what I mean to say is basically with the help of drilling and blasting system, we can actually achieve wonders, provided we must have a practice of doing the things in a scientific manner. These are all different photographs of the same Mumbai Metro project site. You can see, and the overback also you can see at the periphery, the crown area, where how beautifully it is controlled. You can see another view of this central cavern. Okay, this is the old one actually, around 4-5 years back, Delhi airport site. This is not absolutely because of this drilling and blasting setup. This is basically blasting assisted mechanical system, I call it. But why I'm showing you this figure is because you can see there is a chiller building, and close to that building there is hardly 2 to 3 meters of distance from where the cutting is started. Okay, this is another beautiful project. This is basically Mumbai Howrah third line railway line expansion project. And if you see the top portion, basically there is existing tunnel. Tunnel is not visible, but the green vegetation that you are seeing, actually, if you go almost 10 meters ahead from that, we will see a tunnel, which is nothing. Then we are actually going to construct another tunnel, 22 meters parting in the right side. So the dynamic loading because of the blasting, and you do not have blockage also. So with all this constant, all this construction works are going on, and it has been, in fact, now it is operational, and Mumbai Metro, Mumbai Howrah railway line third line project is completed. And this tunnel, actually, I tell you, the speed that has been granted by CRS, that is Chief of Railway Safety, basically, is 120 kmph. So this is what the achievement of this particular project is. Coming to the next slide, this photograph actually I have kept deliberately just to understand this. When we say overbreak, or when you do not practice the blasting in a scientific manner, what damage can be created to this? And when you do overbreak, means over excavation beyond the intended line, then this kind of excavation, and you are going to fill it back with concrete or shortcut, and additional marks you are laying, the damage that you are getting to rock mass, so you need additional supports. So all these problems are actually culminated when you do not do right kind of actually control blasting techniques. So you can understand the difference between these two. I will show you some more figures also. Okay, this is another case study what control blasting technique can do. This is actually NTPC Coldham hydroelectric power project. I will show you in a very, very difficult adverse geological condition how a control blasting technique can achieve what is called stable benches. Let's see. So this is basically a project site before starting. This is in the Satluj River. You can see the left bank and the right bank. Now I will show you the next stage. This is another way. There are different villages which is called Harnola, Chamian, Kachol, and Kyan. I understand many of you from the audience would have been visited or maybe have been associated with this project also. Now coming to this, if you see this, the point that I want to stress here is, if you can find out, there is a pond, and beyond that there is another. I will show you here. I will just move this right. If you focus on decanting area, and from that in the right side you can see there are benches. There are almost 10 benches. They are 10 to 15 meter high, and they are almost vertical. And this is to be excavated from the virgin rock mass. And there are different structures. There are villages where this decanting is written. Actually, there is a village actually, Chamya village, which they call it actually. So these are all different type of benches excavation has been done, and I will show you the photograph actually. This is actually you see here. You can see the half barrel actually marks. That is what, if you come across these contextual documents, you will be forced to show that the blasting expert should show at least 50 to 60% of half barrel marks. And you can see here, even in an adversely geological condition, not actually ADG, but in a fractured rock mass, jointed rock mass, this is basically limestone, pink limestone, and there is a huge intense folding also. Then also your drilling marks are visible. You can see here also. I will show some more photographs. You can see all through this. Here also you can see in my basically the left one is enlarged on the right side. The top portion, if you see, even in this folded rock mass, the half barrel marks of the holes after blasting is visible, and this is almost 15 meter of bench height. And finally, the all the 10 benches that you can see from here, they are so beautifully excavated like this. So coming to this, so with this background actually, now what I mean to say is, if you do the things in a scientific manner, you have a sound understanding of the technical matter, how it works, possibly we can contribute in a very different way, and we can do a good job. So what actually is a drilling and blasting system? I am going with some basics because I understand most of you are actually from a different background, and this will be slightly difficult for you also. So any excavation is nothing but it's breaking into small pieces of the rock mass. And if you see and go to the side, the rock mass is available in different block sizes. It may stretch right up to 100 meters also. But with the help of excavation process, what we are trying to do is reduce it into smaller sizes, which can be handled with the help of our mucking equipments. Possibly that means reducing to a size lesser than 1 meter square or passing size less than 1 meter square. So what we need to do is basically we'll have to give some external energy which actually exceeds the peak strength of the rock mass. And that is done with the help of two things. One you know is a mechanical system, what today morning Gupta Sahab has explained. Okay. There are full face machine, there are partial excavation methods that has already been taught to you today morning, so I will not focus on that part. What I will show you is yes. So there is one point that I would like you to understand, and that is what is the fundamental difference between a blasting and a machine excavation. In machine excavation, what we are doing is we are giving external energy with the help of some controlled regulatory mechanism. We give more time and lesser amount of energy in a controlled way. But in case of drilling and blasting system, it is not like that. Once an explosive is initiated, you do not have any control on that. So basically, we are giving a large amount of energy in a very small time. So that's fundamental difference. So because we have a regulated supply of energy in case of mechanical system, the damage is less. Or if you are not planning properly, you do not have any control on that. But in case of blasting, if you commit mistake, you do not have a second time to revisit the thing. So the very first trial itself has to be in a very scientific manner, in a very controlled way. So what are the fundamental differences? Of course, we know mechanical system is a much higher productive. And I would just like to show you some figures. In one of the projects, we are getting 20 to 25 meters also in a day. That is the advancement that we are getting with TBN system. But the capital investment is very high. In case of mechanical system, a tunnel boring machine, almost 1,000 crores is basically starts with that. Whereas in case of drilling and blasting system, you need a drilling machine. And the whole system can be initiated with the help of 50,000, 60,000 rupees investment. And another issue is actually size and shape constraint. In case of tunnel boring machine, we have a size constraint, we have a shape constraint. Whereas in case of drilling and blasting system, that problem is not there. Any shape, any size can be handled with the help of different sequences, with the help of different sizes. And in case of geological investigation, you know that any kind of geological investigation can be held with the help of drilling and blasting system, because we can always control before that what part of the area of the rock mass of the section of the construction area is to be handled, but that cannot be done with the help of. But in case of mechanical system, we need to have first in place extensive survey, extensive investigation to ensure that the selection of the equipment is perfectly matching with our geotechnical environment. This is very, very important, because we have in India large number of case studies wherein the tunnel boring machines are still stuck up. That problem is not there with the help of geological investigation in case of drilling and blasting system. Another problem is actually what we are facing in Himalayan geological condition is because the road infrastructures are not that good. And to transport this material, the mechanical system, so heavy system, possibly we need to retrofit the bridges, we'll have to widen the road. Fortunately, that thing is also in progress, but it's important criteria that the transportation facilities should be available. And in a nutshell, even if you see much more excavation we are doing with the help of TBM in metros also, but then also drilling and blasting system cannot be eliminated, because there are so much of excavation which is to be done only with the drilling and blasting system or splitters. And in case of splitters, there is a heavy problem. So the way ahead is basically how to enhance our technical competence in this drilling and blasting system, so that selectively and scientifically we can apply it. And fortunately, we are having lot many cases wherein we can see successful application of control blasting techniques, even in a very heavy urban built environments. So, in a very simplistic way, a conventional drilling and blasting system, actually it can start somewhere around drilling system. We need a drilling machine. Let us start with survey actually. First, let us survey this, and you mark the profile, you drill the holes, and load. Load is a term which is normally used in blasting science to put explosive into the holes. Okay. And then after loading, or what is called alternatively charging, you take blast. This is basically initiation of or detonation of energetic material. Once it is done, then the face is ventilated with the help of mechanical system or blowers. Then excavation is done, and then you do support system, scaling, and then support system. So this is one simplistic way of understanding how the conventional drilling and blast system go ahead. This actually I want to show you because I understand some of you might have not actually seen what and how the system works. I know you are all aware about the drilling machine, but there are recent advances where what we call remotely operated multiple jumbo drilling equipments are available. You can drill 3 holes in a time simultaneously. They can be remotely operated, and you have completely mechanized system. Whatever drilling pattern you want, you can fit to the system, and once the machine is positioned, it can take care of the drilling. So that is the recent advancement. Now, once you have drilled this machine, what we do is we need detonators and then explosives and a system which is called exploder, which is in your right bottom side. So these are all some simple things that is required. So you need to understand there are 2 things that I will try to focus because that is something new. One is explosive, and second one is initiating device. How it works, and we as a civil engineer, what is our perspective when we come across a situation like this? How to handle that part? That I'm trying to give you some explanation on that part. But before that, let us try to understand actually what is a blasting. What does happen when we put some explosive inside a hole, and once the energy is supplied, what are the things that happens within a fraction of a second? So the first term that I'm going to introduce is detonation. You see, the energetic material or the explosive, when you give some shock to it, it detonates. Detonates means very fast burning, and which is accompanied by release of energy in a very short duration. Then actually the energy consists of two parts. One is called shock wave and another one is gas pressure. The shock pressure is actually one that creates cracks in the rock mass, and then shock wave basically it leads to what is called radial cracks and tensile cracks. And all these small fine cracks, they are basically filled with the gas pressure, and this gas pressure basically extend this radial cracks or tensile cracks, leading to flexural rupture, and this all combined together that gives us fragmentation and the throw. The picture that you see in the left side is basically the cavity where the hole is there, and around that there is a crust zone, and as you move away the size of the rock mass is actually getting higher and higher, but close to that hole there will be intense crushing of the rock mass. So this is all happens in a single hole. But just to explain you some of the basic understanding, basically what is an explosive is, any explosive basically is nothing but, in a very simplistic way, something that burns, but the difference is basically it burns in a very fast rate. Fast means around 4,000 meters per second. So when it burns, I mean to say, it actually have a combustion which is work as a fuel. Then we have a combustion which is called oxidizer, because it is what supplies oxygen when it's inside the hole. And there are some chemical combustion to make the product stable. So fundamentally for us, it is a material which have basically fast burning rate, more than a sonic velocity actually. So that is called detonation. And this is how it looks like. You please watch carefully. There are some just which is written on this cartridges. This is normally called as a cartridges. You see Superpower 90 or Power Gel 101. We have in India some good multinational brands which actually produces this, which produces good amount of this energetic explosive material, and these are all basically used in underground operations for casting. This is one term actually I wanted to explain you. You see here you are seeing 601, 901, and here also you see this Superpower 90. What I want to show here is basically the material comes in a different with different properties. One of the properties basically is strength of explosive. Strength means basically what is the measure of release of energy. See, this 90 means 90% strength. It is 90% release. It's basically reference to one old explosive which is called blasting gelatin. So let us not go into that part. Basically, what I want to say is when it is 90, it is 90% strength. This is the most powerful which is available. If you see here 601, that is basically 60% strength. So when we talk about what is the use of this, so when you go to the site, you can see what type of explosive the contractor is using, and if you see that there is a overbreak or there is some rock mass damage, you can always insist him to use 60% strength or 90% strength accordingly as per the rock mass condition or as per the strength of the rock mass. Then we have some other properties that I understand you should understand. One is strength that I just explained. Velocity of detonation is basically the cartridge that I show you, basically how fast it gets consumed when detonation starts from one front to last cartridge. So how fast the detonation front move. So that is basically speed. So velocity of detonation is basically how fast a detonation front move within a hole. That is velocity of detonation, and that is also accompanied by release of detonation pressure. So strength, velocity of detonation, and strength pressure, detonation pressure. These are all important parameters. Apart from that, there is another parameter which is called sensitiveness. Sensitiveness is nothing but, as I told you, all these explosives need some shock to initiate. And when we talk about this sensitiveness, basically, how fastly or with what amount of shock this detonation is achieved in this explosives, because that is one of the most commonly reason where the plastic fails. If it is not sensitive or it is not optimum sensitive, possibly the detonation will not start, and that becomes very dangerous situation. So it has to be optimally sensitive, number one. So these are all something that we want it to be high. The next part is basically low. Sensitivity, that is different than sensitiveness. Sensitivity is basically how this energetic material behaves when some external shock is given. External shock means basically while handling the materials during transportation, it should not get initiated, because there also we get some sort of shocks. And another important part is basically these materials, explosive materials, they should have a water resistance property, because we encounter this hydrogeological condition in the rock mass. We'll hardly get completely dry phases, and this is fume characteristics is also equally important in metro site. Particularly, you will the air quality monitoring is actually done, so explosive generates a lot of fume, so we'll have to see that oxidation takes place, and though this nitrous fumes are generated, so we need to ensure that this fume quality is actually of appropriate quality. There is no negative oxidation, and this what is called production of nitrous fumes or carbon dioxide. All those gases are coupled, so that should not be there. And just to introduce you, these are all what you'll see. This actually have put you categorically just to understand what is a good explosive. Well, just by seeing this, you can understand the difference in these three. You see the one which is at the left side, which is SBL energy. You see the cartridges are intact. It looks perfectly in shape. But the one which has actually, say it is not properly handled, it has been manufactured and it is quite old. You can see it is not able to retain its shape and size. If you see this, you can understand the quality deterioration is there. And there is a critical density also that actually, in fact, I did not touch, because if the density is changed, possibly that explosive will also not initiate. So these are all small quality checks that you as a civil engineers can see at site and can understand the matter, what may happen, what may not happen, right? Okay, there is another thing. You can see the bottom portion in the right side. What these people are doing, you see 2-3 cartridges they have tied together. What is happening in a remote site? What is, suppose we are having a hole diameter of 45 mm and the cartridge available is 25 mm of diameter. What they do, they will tie together and will try to insert this. This is not the correct practice, because this actually makes a difference in a technical way, which is called coupling of explosive materials. What is the angular space we are leaving between a hole and cartridge wall? That's very important. You cannot keep it very large. At the same time, you cannot keep it very tight also. So this makes difference. So there is an optimum diameter of hole and there is an optimum diameter of cartridge also. Another important part is, as I told you, velocity of detonation is something that measures release of energy content in explosive. So with the passage of time, this is important, because when you go to the remote site, actually there is a tendency that the explosive supply will be delayed. You will be getting supplies even after 3 months, 4 months, 6 months time. So with the passage of time, basically it loses some of its fundamental properties, and that is velocity of detonation. So almost 15 to 25% loss of VOD is quite common when you are going in a remote project sites, and that actually accounts for your loss of production. So when you are going to analyze all those parameters, you'll have to take care of this part also. So this is something in a very what is called preliminary things about explosives. I just tried to introduce you. I just have a figure in your mind. How does it look like, and what are the things that you need to understand when somebody talks about drilling in blasting system? So the first thing is basically we need an explosive. An explosive, it comes in a different shapes and size. Starting from 25 mm, it can go up to 83 mm also. So just have something in mind. The weight is actually 125 grams, and then The largest size, which is 83 mm, that comes in 2.798 kg. So that is a variation in size. So now going ahead, apart from explosive, we need an initiating system. Every explosive needs some sort of shock to achieve its optimum velocity of detonation. And for that matter, we use initiating system, and loosely we call it actually detonators also. So there are different systems: shock tube, detonating fuse, safety fuse. Safety fuse is the oldest version that you will not come across in infrastructure projects. I will just try to explain this. What is it actually? If you see the firecrackers, the top portion with which we actually give this what is called first preliminary energy for its initiation, that is basically pyrotechnic combustion. So the top thread portion that you see, that is nothing but a sort of safety fuse. Okay. Now, in a more scientific way, in a refined way, we come across a different situation, which is detonators. And if you see this, there are plain detonators, instantaneous detonators. Then we have a delay system also within this, which comes in a short form or long delay detonator. We call it long delay detonator. We call it short delay detonators. Why it is required? Suppose you are dealing with a cross-section area which is almost 50-60 square meters. You will be having more than 100 holes, and you cannot blast all these 100 holes. So what we do is we allow them to fire in a sequentially controlled manner, and for that we assign them some different delay time, predefined delay sequences. So that is done with the help of this delay detonators, which is actually short or long. Short means it is actually 25 millisecond of gap between two successive holes, whereas in case of long, it is 500 milliseconds between different holes. Then the latest update is actually electronic detonators. I will show you some photographs. This is how it looks like. Just to have some physical knowledge in your mind, the size is around, the length is around 8 to 10 centimeters, diameter is around 1 centimeters, right? And there is two wires coming out. Okay, I will show you its section actually. How does it look like if you cut it? Okay, it's not going on. Excuse me, I think there is some hang, it seems. Okay, it's going now. Start moving. Oh, sorry, but it still will continue. Okay.
No problem.
Now it's okay. Can you hear now? Can you see this audio? The presentation is visible to all of you?
Yes, but the same slide with the red one and two.
Okay, it's not moving up. Oh, right. Let me just. Okay. Just I think. Anyway, we'll continue with the talk. Actually, I will in the meantime I'll try to start that open from here. Okay. So I was talking about the detonator system. In that system, actually, there are 2-3 things that you will hear quite frequently. One is shock tube initiation system, and there is a term which is called non-electric initiation system. Just now I showed you this electric detonator system wherein you saw this twin wire coming out. So that is replaced by another system which is nothing but a simple tube. So that simple tube is carrying the shock. Yes, I think it is visible now.
Yes, it is visible.
Okay, let's see this now. It is visible. Then I will just put it. Yes. So the term I was talking about is basically non-electronic system. A non-electric system which is actually used in this metro power projects or in urban built environments. So the denominator actually I was trying to explain you, this is how it looks like. But fundamentally just have in mind that these are all the denominators which looks like this. Then with all the system, the recent advancements is basically there is a system which is called electronic denominator system. That is nothing but advancement from this recent technique, which does not actually fail, and we can also assign predefined delay time, which does not have a limitation of 25 millisecond or its multiple or 500 millisecond or its multiple. We can give any XYZ numbers. So with that, actually, you can optimize the blast design in a more what is called precise manner. I think this is what I'll just skip. This, right, I'll go to the next one. Yes, this is what I was just talking about. If you see the section actually, this is a pyrotechnic electronic detonator. You see the complex electronics which is inside this. And this comes around 1,000 rupees per piece. You can also have some idea. This is how, you see, it has got its own application specific integrated circuit. So virtually no possibility of any failure, absolutely safe, 1 in trillion chances of failure, and safe. It does not work alone actually. There are 3-4 systems which works in conjunction, and then only this whole operation can be done. So, but this I will move to next. Okay. So with this background actually, now the next thing that I would like to develop is now how its use is done so that we can get some desired result. For that, what we need to understand is we need some desirable and some unwanted effects are also there. Breaking up the rock mass in desired sequence is a primary requirement. We want the rock which is broken to be displaced, and then we need a good production, higher pull. But during all this process, what we also have is actually problem of ground vibration, air blast. There are flying fragments if you do not control it. Then in our civil engineering projects, these projects, we mostly deal with the problem of ground vibration, damage to the rock mass, and increased cycle time. I'll go to the next. Okay. Now, if you see a section of tunnel, actually we divide it for the purpose of blasting in this 3, 4, 5 parts. Now please focus on the first part, which is cut, which is A. And then they are surrounded by 2 parts, which is B, which is written as a stopping. And then C is another stopping. And then D, which is contour, and then E is a lifter. So this is how the sequence of excavation within a tunnel should move on. The first part is you have to design a blast in such a way the cut portion should be moved out, and then that works as a free face, means the space for the broken rock mass to move and swell, because that is how we are reducing the vibration. So A and then these 2 B's are to be moved out, then your C, and sequentially then contour portion and the lifters. This is how the sequence moves. Most important part that I would like to drill here is, you see, what is the tunnel blasting guiding principle. A typical tunnel blast design is actually there in the right side. You just see this, there is a term which actually used in the few minutes ago. This is progressive enlargement of the free face. I'm sure you all understand this. Then firing up the holes towards maximum free face. You see 1 and then 2, 2, 2. Imagine now the B stopping area and then C area. So likewise it moves, and planning a firing sequence to have maximum free face at the bottom of the tunnel so that maximum stopping can be done in favor of gravity. And every time you have to ensure that the creation of the maximum free face before the contour holes are blasted. Then only you can ensure that the damage is reduced. Now the same principle has been applied here also. You see, the first cut hole has been done at the center. Then if you see the right side second photograph, the top one, the free face is created, and then now I am enlarging that in the right side and the left side, and gradually I am getting my tunnel excavation. So this is how it moves. You see, simple. This is not that important basically. What I will go is actually, yes. Let us give you some simple empirical correction that will help you. You see this number of holes per round. If your diameter is between 30 to 38 mm, if your tunnel cross-section area is around 10 square meters, in a V class you get around 23 to 27 square meters. And then in a stung rock, actually it goes up 35 to 50. That is quite logically common. Then as your cross-section area goes on, number of holes in explosive, of course, that will also go on. So I will share all this thing with you. I think that will be helpful to you. Another important part that I would like to share with you is how do we measure the tunnel blast performance? Because we will not be directly into the execution, but if somebody reports to you, these are all the things, these are the parameters that has been used in the blasting operation. Possibly with these thumbnails, you will be able to understand what is a pull. If you are having a hole depth of 3.2 meters, what is the advancement of the face you are getting? It can vary from 1.5 meter to 0.8 meter to 3 meters also. If the rock is very, very weak, you will not be allowed to 3.2 meters. You will have to restrict to round length, maybe 1 meters, 1.5 meters also. So, but what we want is actually maximum advancements. Maximum advancement means out of certain drill depth, what is the percentage of advancement we are getting for that particular round. Then specific charge. You will come across this term also, which is nothing but what is the explosive amount you have used for per cubic meter of rock excavation. Lesser is better. Then specific drilling. Drilling is a very, very costly operation. You know, it starts from 4,500 or 6,000 meters rupees per meter. So our intention is always to ensure that with minimum drilling, what is the maximum advancement we can get? So what is the drill run of depth that you are getting to produce certain amount of rock mass? That is specific drilling. Similarly, hole factor or detonator factor. So there are basically some of the parameters that you can easily understand. But just to give you some idea, this is how you can assess the performance of a blast in a tunnel. Some more thing that I would like to tell you. This is very, very interesting, you know, specific drilling. What I want to tell you here is when the cross-section area of the tunnel is smaller, it is very, very difficult to take blast. And for that reason, actually, specific drilling is high, specific charge is high, pull is less. But as the size of tunnel increases, blasting becomes easier. And accordingly, your rate will come down. So all those indicators, specific drilling, detonator factor, hole factor will come down. And you see the sharp decrease from 1 to 2. When cross-section area is around 15, it is very, very high. But as you move beyond 35 to 40 square meters, which is normal our HRT size, it becomes almost optimized. So what we need is actually in a very, very 1.2 to 1.4 cubic meter kg per cubic meter of rock excavation, explosive will actually give you a good advancement. So these are all the parameters that you can have. Similarly, specific charge also. The smaller is the size of a section area, you need proportionally more explosive to get excavation. But as size increases, you need unit amount of explosive will reduce. Okay. This is some interesting finding that I have shared also earlier in some of the presentation. I would like to share with you once again. You will have to understand the joint. When the joints are normal to the tunnel direction, it is favorable for good pull. But if the situation is different, this is the case where your joints stucking parallel to the tunnel advance direction, you won't be getting this. So if this is the case, just barely by increasing the explosive quantity will actually damage the rock mass. It will not give any good results. It will not be improved. Right? Similarly, if right side wall is more prone to the breakage with joints at an angle to tunnel direction, you will tend to get some overbreak in one direction. So these are all some small insights that you need to understand. Right? Now let us go to this quickly controlled blasting technique. What are the fundamental guiding principles and what are the takeaway for us as a civil or geotechnical engineers? So fundamentally, any control blasting techniques are techniques wherein we try to reduce damage to the surrounding rock mass to a minimum level. It improves the competence of the rock by restricting growth of uncontrolled fracture. And then at the end, what we are getting is the load carrying capacity of the rock mass is retained. We are trying to do that. We do not create a problem for the rock mass so that inherent strength of the rock mass is not lost. I will show you some figures wherein you will see that how the strength is getting reduced. And of course, the desired roof coverage is very, very important. And let's go to this. So what we do is basically in any control busting technique, the governing principle is the spacing of the hole. They should be closely spaced and it should be decoupled. Means the diameter, the angular space between the explosive column and the hole within and the whole wall within a hole, that should be decoupled. There should be some angular space, because if you allow some aerial space between these two, there will be adiabatic expansion of the detonation pressure, and ultimately the pressure on the rock wall will be less, and therefore the damage will also come down. The explosive charge should be distributed within the hole, and there should be less delay between consecutive holes. So these are all the guiding principle which actually helps. And there are 4 techniques: line drilling, twist-pitting, smooth wall blasting, and cushion blasting. But in case of underground infrastructure projects, what we are mostly coming across is smooth wall blasting techniques. So I will show you some photographs wherein this thing has been done. What you need to understand is in any smooth wall blasting, if you see the contour area, the tunnel profile, you will see that you see the topmost crown portion of any tunnel blasting, the spacing of the hole. Unfortunately, I could not show you actually how it is charged, but closely spaced, and the penultimate row of hole and the ultimate row of hole. These two have smaller spacing. And then you see the firing time also, that is also quite high. So these are all the fundamental techniques, but you please remember what is a smooth wall blasting technique, which is actually used in underground excavation. You can see the results also. This is one single point boring tunnel project in a very, very hard rock also. You can see the profile of the rock mass. And when you do not use control busting technique, the figure that you are seeing in the left top corner is what is called extensive damage to the rock mass, overbreak. Whereas in case of the right bottom, you can see the line, the hole marks. That's basically, of course, this is I have taken from the net, just for your reference. So I will. This is what I want to show you. You see the left bottom side, the desired curvature is something different. We inherently get some overbreak, but beyond overbreak also we damage the rock mass. And these are all some photographs you see. It is a granite rock mass actually. With the blasting, where it has been actually, I just wanted to show you, even with the cut saw, you can see the red marks, which is basically inks or color, which has actually put it into joints. Just to show you that even if you are getting a half barrel marks, the damage is much beyond that. It's not that we are getting half barrel marks and the damage is restricted to that. It is not only that much. I will show you. You see, let us see this. If it is tunnel cross section area, there is a design profile. Beyond design profile, there is an overbreak zone. Beyond the overbreak zone, there is a damage zone, and that also there is another area which is called disturbed zone. So overbreak zone is basically simply over excavation. Beyond overbreak zone, there is a damage zone. Means there is a irreversible changes in the physiomechanical properties of the rock mass, and beyond damage zone, there is a reversible zone wherein the rock mass properties which has been lost because of the blasting over a period of time, that will be reversed back. That happens actually. So this is what I just now explained you. And these are all some parameters actually that I will not do. I will just show you some experimental results that will be more helpful. I have actually conducted some experiments, and I will show you. These are all the case studies of 3 project sites, and they are mostly hydropower projects. I will show you some data we have collected in this manner. Tunnel blast we have performed. We got some data, and rock mass characterization we did, with different parameters, and we did extensive vibration monitoring also. This is actually single event very hydro power project. We are seeing headrest tunnel. These are all the vibration monitoring equipment that we have used. Consists of geophone and mics, and
So your audio is, your audio, yeah, आपका time हो गया है.
it is not something which is going to play a pivotal role in generation of vibration. What will make difference is basically in a 8 millisecond delay time, what is the amount of exposure you are firing. That makes difference. So that is called maximum charge per delay. So we need to distribute the explosive in a small parts, assign certain delay time, and smaller is that amount for a delay for a particular delay time, smaller will be the damage. That is what I want to say here. And this I will not have to explain. Okay. So these are all some empirical correlations that we have actually tried to understand, evaluate, and this actually I will share. I think you can see this in some of my papers also, which is published in Tust and JRMTT, which is also available. You can see this in rare conference also. Of course, this is one of the important actually part I would like to say, scale effect analysis. See what is happening. This term, those who are into numerical modeling, they understand this term actually. This is nothing in this case. Actually, it is a ratio of basically tunnel cross section area and the block size. Okay. So, if the block size, if your SI is lower, means opening in fractured rock mass, or if it is opening in a massive rock mass, then this can help you to understand how it has impact, what is the impact of this complete operation on overbreak. It's something different because we have some dispute with the contactors. Many times it is a rock mass which is creating a overbreak, or it is a blast induced overbreak. This you can use to delineate between these two parameters. And this, of course, this parameters you can definitely. I will go into more this. Okay. Another important part is actually how to get this extent of damage distance. For that, I have used this blast vibration data and did some regression analysis with cube root scale. We got the attenuation characteristics of the vibration. Once I have this attenuation characteristics of the vibration, then I know what amount of explosive will give what amount of particle velocity at a certain distance. If I know this, then I can draw this curve, right? Which is nothing but particle velocity and distance. If I have this curve, I also know what is the critical peak particle velocity at which the rock mass will damage, which can be calculated with the formula which is given in the left side. And then you can understand, say for example, basaltic rock mass, if it is suppose getting damaged at a distance of at a particle velocity, critical peak particle velocity around 1550, then even the distance up to 1 meter is damaged. That is how you can actually compute. I will show you some more thing. So based on then actually some blasting exercise we have done with all this background, and I will just try to understand, show you how beautifully the results can be obtained in a tunnel blast, virtually with no overbreak, and it is a fantastic progress. Now, these are all some photographs. Anyway, I will show you some more recent work that we have carried out. This is basically on a hydropower project. I will just try to tell you actually what is happening inside the rock mass at a very, very microscopic level. This is what we are seeing in the surface level. I will show you. What I have done is actually I have drilled some cores from the tunnel after excavation, right? You can see this cores. And then I got this. This is basically triple tube core barrels. It's very important that I use triple tube core barrels so that during drilling we don't induce fractures, right? And then we calculated different. These are all the cores actually. You can see such a beautiful cores, right? Now imagine what is core recovery, what is RQD and maximum core length. How it varies with distance away from tunnel opening, right? So you see here the maximum core length in RQD that is very less in the first 1 meter of the tunnel in the rock mass. But as you move away, it is gradually increasing. That is actually an indication of basically the rock mass damage, the extent. I will show you some more qualitative figures. These things actually quite obviously it happens actually, and it is in a biotite rock mass. Then we did some ultrasonic tests, and you will see that it's very interesting. You see, the rock mass immediately at the opening is having. I will just give it time. Yes, you see here the rock mass. Say for example, at a 5 meter distance, we do not have any damage to rock mass. So the PU velocity is almost 3,500, something like that, or at least 3,000. But in the first half meter, after overbreak, you see it has come down to almost 26,000-27,000. So you can actually very easily correlate the difference in VP, how much actually it will make change in the strength properties. And I will show you these are all the differences. And there is an interesting paper also you can see when there is a 10% reduction in the PU velocity of the rock mass, that is counted as a damage distance. So the distance up to which there is a 10% reduction in the PU velocity, that is counted as a damage distance. So you can find out actually how it is varying, right? Similar is the case here also. I will show you another example. Then I did some strength test. See here the results. The rock mass which is having a strength of almost 48-50 MPa, in the first 1 meter it has come down to almost 41-42. 15 to 20 meter of 15 to 20 MPa of loss. So these are all the things that we need to take into account while designing a support when you're taking a blasting operation. Right? This is a composite figure, the same thing that I wanted to show you here. Let's go on to next part. This is another very recent research that I would like to share with you. What I did is actually from the same course, I prepared some thin sections. And from these thin sections, every half meter, from the first half meter, then 1 meter, 1.5 meter, like that, I moved on, right? So, and then I analyzed it. What I want to show here, you see, if you see the changes in the fracture, even at a microscopic level, close to just tunnel opening. This is if you move from clockwise, starting from left top, okay, then you will see that number of cracks is very high in the rock mass which is close to the opening. As you move away, then the number of fractures, the size of cracks, they are all reducing, and there is a constant shift of these cracks from the grain level to the body. I'll show the next one. You see this? You can appreciate the difference between these two. And when I go to the next, close to how, I say this is almost 4 to 5 meters. The grains are intact. There is hardly visible any fracture. So this is what I want to show you. So if you analyze the data in a very microscopic level, you'll have to show that our drilling and blasting process is actually scientific, and we do not create damage to the rock mass. That is equally important. So these are all some actual photographs that I have collected from one of the site, and you see this, the whole section actually, which I was theoretically explaining you. Same thing you can see in the rock mass. There are intense fractures close to the rock mass that are propagating in a radial direction. And you please see that the rock mass is quite competent, and the cracks has actually created a fracture in this. And unfortunately, this photograph is from the dam site. I will show you one more photographs. You see this? So these are all the things that I wanted to share. This is one important part actually, because we come across a lot of problem wherein we keep fighting with the perception part actually. Blasting is perceived in a different way. Educated people perceive this blasting operation in a very different way as compared to somebody else. If somebody who is engaged in the project site is an employee of the project, possibly his tolerance level is quite high as compared to anybody else who is not getting directly benefited for the projects. So these are all the things. When you come across a blasting site, you need to fight all these things, and then it becomes absolutely difficult to make them understand it's not because of the blasting or it is because of the blasting. And we carry very extensive program for this, right? So this already explained to you, and I think with this again I would like to repeat the guiding principle of the tunnel blast. If you do it in a scientific way, possibly we can create a miracles with the blasting also, and we can actually contribute in a very different way. So with this, there are 3 parameters that you need to play around. Please remember this. One is energy distribution, means how you are actually distributing explosive within the hole. Then energy confinement. What is the selection of your diameter of explosive and hole diameter, right? And this also means if your tunnel cross section is very small, if you are having 15-20 square meters of tunnel cross section area, you cannot drill a hole depth of 3 meters. That you need to understand, because that will increase confinement. So that is also called confinement. And the last part is energy level, which I explained you 601 or 901 or 801 what you want. So if you have a right kind of energy confinement, right blasting pattern, correct explosive, possibly there should not be any problem with drilling and blasting operation, and we can go on doing drilling and blasting. So with this, I would like to conclude, and I really thank you very much, Dr. Khan and the team, for giving me this precious time. Thank you very much.
Thank you, Harsh Verma sir. Very lucid presentation and a very good presentation. Lot of insight into drilling and blasting. I will request Professor Mehboob Anwar Sahab to say a few words as a
Okay. Okay, sir. Okay. Thank you, Harsh Kumar, Dr. Harsh Kumar Verma, for your informative and nice presentation, and for giving the idea you for the explosion used for the explosive material for explosion and for the blasting. And Harshvardhana, may I request you? I want to ask the few questions, sir. What is the difference between the explosion and the blasting? So actually, and the spacing of the drilling, because we use the chemical, the explosive material, which is a chemical used for drilling in the holes. So the spacing of the holes remains same for all type of the rocks, or it vary, or it is the design, or depend on the strength of the rock.
So thank you for this question, sir.
Actually, for blasting, the chemical energy is changed to the mechanical, and then to the heat energy, and the rocks are disintegrated. Okay. So, sir, have any code for the spacing of the for making the drilling in the rocks?
Sir, thank you very much for this
The
question.
spacing remains same for all type of the rocks, or it vary?
No, sir. Actually, see, of course, the answer is
Sir,
no.
am I audible?
Yes. Your question is well taken. Dr. Verma will be answering you.
Sir, am I audible?
Yes. Your question is very well taken, sir. आपका सवाल लिख किया गया है. Now,
Sir, Harsh Kumar Verma, sir, my question is that.
Sir, I got sir, मुझे question पता चल गया, sir. I got your question.
Okay. Please tell me, sir. Sir, one question I ask you. One question is also, what is the difference between the explosion and blasting?
Sir, okay. So let me come one by one, sir. So the first explosion is blasting. See, fundamentally the terminology, if you go into the mechanics of the work that takes place in these two are same actually.
Okay.
Right? Now, when we call this plastic, then we talk about we are actually using some explosive to break the rock mass into smallest pieces.
Okay.
Right? That is actually rock blasting. We call it rock blasting, right? And of course, there are other explosive usage also, which actually takes place in a different way.
Okay.
But fundamentally, what we do, rock explosive is some use of explosive is explosion actually. In blasting, we also use explosive that is actually chemical. So
Okay.
it is not like that. The difference is basically in the purpose. Now coming to the next part actually, what are the drilling and blasting pattern guidelines? That actually,
Okay.
sir, I tell you honestly, I skipped. There are actually a lot of empirical correlations. There are a lot of text actually. I can share that also because see, covering all the aspects in a one go would have been very, very difficult. So I actually kept it aside. I just wanted you to come across with some of the terminology which is new for the civil engineers or for the people who are actually not only into this execution. So I have tried to introduce the subject matter and tried to give you some perspective and insight. Now, the drilling and blasting procedure is entirely different for different rock mass, for different shapes and size of the underground opening, and
Okay.
of course, the parameters are rock mass. There are certain parameters which does not have any control for us. Say, for example, the rock mass is one thing which is we do not have any control, but there are controllable parameters like your drilling pattern can be suited, customized as per your requirement. You can always change the kind of explosive materials, initiating devices that you want to use for the rock mass. And
Okay.
there are good empirical relationship, but in blasting science, basically, as you know, in rock mechanics also, we deal largely with empirical correlations. That is very, very successful now also. So what we suggest is actually for every new site, we take some trial blast. Trial blast is basically you have some thumb rules, you have some empirical correlations,
Okay.
you take some trial blast, and based on that, you refine your understanding the response of the rock mass, and then you go for the full-fledged work. So that is what the system goes on.
Actually, sir, one more question.
Please.
In case of the soil strata, the TBM machine is used for making tunneling
Mhm.
under the road. Okay, okay, we can use the TBM for making the tunneling. So, sir, we can we use the TBM in the rock for making the tunneling in the rock, or without TBM we can make the tunnel in the rock?
Okay, sir. Sir, see, TBMs are manufactured with a very, very different, well-defined range of application. When we talk about soil, then we use a machine which is called EPBM, okay, earth pressure
Okay,
balancing machine. When we
okay,
talk about hard rock tunnels, they are different tunnels basically. The complete mechanism is very, very different. See, today morning Gupta Saab was explaining to us actually the machine when we are doing excavation at a shallow depth, mostly encountering soil, you need earth pressure balancing machine, pebble sheet machines. But when we talk about hard rock machine, then
okay,
the cutter head design is completely different. We need to deal with a very, very hard rock mass. So that is
okay,
these two are very, very different, sir.
okay, okay, okay. Sir, can we use the TBM of the soft rock?
Yes, we do, sir. In India also, in fact, Delhi, a lot of EPDM machine has been used. We are
Okay,
using it.
okay. Oh, sir, without blasting?
Of course, blasting. See, if it is soil, we don't need blasting. We need
Okay,
blasting when the rock mass is hard. If,
okay,
if there is a soil, we can excavate it with 3 cubic meter of large size of excavator machines are available, which is good in strength. We can do that. Even in a very, very difficult situation, we are using breakers for dealing
okay,
with rock mass even up to 100 MPa rock mass, 100, 120 MPa strength. But when you
okay,
talk about soil, possibly we don't have to go for this. One is soil, and another one is basically when the rock mass is very poor. Rock mass is poor means the quality of the rock mass is poor.
oh, yeah,
Not
yeah,
talking about the individual units. The rock mass is poor. Rock mass is poor means even if there are multiple fractures, that rock mass can also be poor. And we don't have to go for blasting. Possibly the excavator itself will help us.
Okay, sir.
There is one question from the participant.
Yes, sir.
Mr. Rahul Kumar has asked that what we do to prevent spread of particulate matter. That is, when we have blasting, we have a lot of sediments which is going into air. So what we do to control them?
Okay. Actually, Rahul, thank you for this question. See, this what you will read a term which is called fly rug problem in blasting terminology. So let us take a case of under urban built environment. If you are not doing underground excavation, if you are doing excavation in a open excavation, what we do is actually there are mats, they call it blasting mats. So you drill hole, and these blasting mats are professionally available, commercially available. So you top that whole surface with this mats, multiple mats, So there are two advantages we are getting with this. One is suppression of sound. Second one is prevention of ejection of this flying fragments. And these are all very commonly used. And unfortunately, I could not show you, but I have got some project figures of mats actually. At single mats are 1 ton, 2 tons like that. It is quite heavy. It is actually built up of this conveyor belts.
Okay.
Is that clear?
Yes. Okay, sir. Thank you, Dr. Harsh Verma and Professor Mehboob Anwar Khan, both of you, for sparing your valuable time for us. And we are. Yes. Yes.
One question more.
Okay. Okay. Yes.
Okay. Sir, please, may I ask one more question?
Please, sir.
Okay. Sir, TBM generally used for the horizontal excavation. Can we use the TBM for the vertical excavation also?
No, sir. For actually vertical excavation, there is a different system actually.
Okay.
I don't know. No, TBM cannot be used actually like that. What we can use actually, there are other systems for a partially mechanized system actually. Make rest paper. I don't know you have heard the term or not. In mining, actually, when we drill this large type of shafts actually, say 10 meter, 15 meter diameter, from bottom upward. Okay, from bottom upward, then what we do is actually there is a mechanized girder system and a motor system actually that can take the crews to the top level. They can drill the holes and then you can blast. But I think I cannot imagine a system which can drill upward with a TBM. I think possibility is not available.
We have shaft borers and raise borers.
Yeah, they are actually yes.
Shaft borers and raise borers, they are especially designed for vertical drilling. Not for.
Yeah, but they are actually top. They are basically top bottom. They are basically coming from top to bottom.
Yes.
Not from bottom to top.
Yes. Okay, thank you, sir.
So thank you, sir. Thank you very much.
Thank you, sir.
This was a very new topic for us. This blasting, though we are teaching it, but a little bit. Now, after hearing you, sir, we will have more of this content in our syllabi. And we would like to have, sir, your PowerPoint presentation. Even the shorter version will do because we have to give it to the participants. And we will definitely be in touch with you for your research papers so that our students can go through them and they will definitely increase their knowledge base, because nowadays we have lot work of underground tunneling and construction. So thank you, Dr. Verma Saab and Professor Mehboob Saab, and the participants also for sparing this extra time today from morning till this time, that is 5:30. Thank you all, sir. Thank you, sir.
Thank you very much, sir.
Thank you.